Alright guys, so this is, let's see, the second part of 1.8, and I am definitely going to go over some of this together in class, but what I want you to do is, if you're watching this video, which I hope you all are, eventually, I want you to take the notes down and put them in your notebooks so that we can talk about those things tomorrow, okay? Alright, so first, I want to find the inverse of y equals x squared. So we switch to x and y, so x equals y squared. And then we have to solve for y, which means we have to take the square root. But when you take the square root, you have to remember that you actually have two answers. You have the plus and the minus. So you get that y inverse is both the positive and the negative square root. Well, when you think about inverses and functions, right? One thing we talked about is how they're reflections across the diagonal. So if this is my parabola, y equals x squared, then the reflection across the diagonal is going to be both the positive and the negative square root. You got the positive square root and you get the negative square root, right? Which together do not make up a function, okay? And the reason why we know they don't pass, it's not a function, is because they don't pass the vertical line test. If this does not pass the vertical line test, and that means its original function did not pass what we call the horizontal line test. So this right here, the original function, fails the horizontal line test. If your original function fails the horizontal line test, then that means your inverse will fail the vertical line test. So when you think about a function that does not pass, or that does not fail either the vertical or the horizontal, something like x cubed, then you don't have to worry about, you don't have to worry about the inverse not being a function. In fact, we know what the inverse is. It's the cubed root. So that passes the vertical line test because the original passed the horizontal line test. Passing both the horizontal line test and the vertical line test means you are 1 to 1. So 1 to 1, meaning, or the way that we write that is that. And that just means, like, for every x there's a single y, and for every y there's a single x. Okay? So for every x there's a single y, and for any y value there's only one x. For every x there's a single y, which this one passes the quadratic. For every x there's a single y. But for every y there's not a single x. There were two different x values that equal that y value. So 1 to 1 are function 1 to 1 functions are the ones that their functions and their inverses will be functions. Okay? So okay. So just what I just said, what has to be true of f in order for f and f inverse to be a function? It has to be 1 to 1. Okay? So f must be 1 to 1 in order for its inverse to be a function and for it to be a function. Okay? So just like thinking about some functions right quick, are the following functions 1 to 1? So you got a cubic function shifted up 3. So cubic function shifted up 3. And yes, that passes both the vertical and the horizontal line test. So it is 1 to 1. When you think about 3e to the x, so 3e to the x is an exponential function. It's an exponential growth, so it looks like this. And then it shoots up really quickly. It does pass the horizontal and it does pass the vertical, therefore it is 1 to 1. This is a quadratic opening down. So if you've got a quadratic opening down, I don't really know where it is. All I know is that it's got a y-intercept of 1 and it opens down, so something like that. It passes the vertical line test, but it does not pass the horizontal line test, so it is not 1 to 1, which means its inverse would not be a function. It would be a combination of two functions. The absolute value of x minus 4 is an absolute value function shifted to the right 4. So to the right 4. It does pass the vertical line test, but it does not pass the horizontal line test, so that is not 1 to 1. And then x cubed minus 4x. So if I factor that out, that's x times x squared minus 4. which is x times x plus 2 times x minus 2, difference per squares. And that means I know that this is a, well, I'll change colors. This is a cubic function that crosses at 0, -2, and +2. So 0, -2, and +2. It's got a positive link coefficient, so it starts from below and goes up. So I know it does something like this. And having this go on in the center means it does not pass. It does pass the vertical line test, but it does not pass the horizontal line test. So it is not 1-to-1. Okay. So just being able to look at a function, I can tell whether or not its inverse will be a function. In fact, if you tried to solve for the inverse of this one, you couldn't. So literally, if I tried to replace x equals y cubed minus 4y, there's no way that I can solve for y. If I factor out a y, I've still got a y squared. There's just no way to solve for y because there is no inverse. Okay. Now, obviously, I could take the x values and, or the x and the y values and plot them and draw it in a weird sideways cubic thing. But you can't find the function that is inverse. Okay, so find the inverse of the square root of x plus 4 minus 2. So y equals the square root of x plus 4 minus 2. Yeah, I'll go ahead and find the inverse, and then we'll talk about domain and range and all that. So switch x and y. Well, x equals the square root of y plus 4 minus 2. We need to start solving, so I'm going to add the 2. So x plus 2 equals the square root of y plus 4. I'm going to square both sides. So that is y plus 4 equals x plus 2 quantity squared, which we're going to leave like that. And then we're going to subtract 4. X plus 2 quantity squared, subtract 4 equals, and I'm going to put the y inverse on this side. And if you stopped right there, then you would be partially correct. This is not the inverse. This is a full quadratic. But we only started with a square root. So when you think about graphing this, because it says find the domain and range. So I can find the domain and range of this without having to think about the graph of it, but I do have to know the graph of this. So this is a square root function shifted to the left 4 and down 2. 1, 2, 3, 4, down 2. And so I've got my general square root pattern, over 1 up 1, square root of 4 is 2, and the square root of 9 is 3. So square root of 1 is 1. Okay. Square root of 1 is 1. Square root of 4, 1, 2, 3, 4, up 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. And that is my square root function. Okay? Now, if someone asks me to the domain and range of that, then I'm going to say domain from left to right. The farthest left it goes is -4. And it goes to the right to infinity. And the range is up and down. The lowest it goes is the y value 0. And it goes up to infinity. Okay? Well, its inverse is this quadratic, kind of. So if I were to graph this quadratic, I would go to the left 2. Let's see. Yeah. I'm going to go to the left 2 and down 4. Sorry, I should have brain fart. Okay. So if I go left 2 and down 4. What was it? I didn't go down 2. I was like, something is wrong. Fiddlesticks. Just kidding. Why am I going left 2? I didn't go. Okay, cute. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So, just kidding. I'm going to go left 4 and 1, 2, 3, 4 and down 2. Okay? Same pattern, over 1 up 1. Over 1, 2, 3, 4 up 2. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. So 1, 2, 3. So here's my square root. Okay, so my domain is still -4 to infinity. But my range, it should be lower. I go down to -2 and up to infinity. Man, my computer went blank. Okay. Now for the quadratic, I'm going to go left 2 and down 4. So left 2 and down 4. 1, 2, 3, 4. And to the right on a quadratic, I go over 1 up 1, over 2 up 4, because 2 squared is 4, and over 3 up 9, right? So I'm going to go over 1 up 1, over 2, so 1, 2, up 4, so 1, 2, 3, 4, and then over 3, 1, 2, 3, and up 9, so 4, 5, 6, 7, 8, 9. And this will be the right side of my quadratic. Now, when you think about inverses, remember they are reflections across the diagonal. With only the right-hand side of this quadratic, I have reflected this square root, which means it's not the full quadratic that is the inverse, okay? This function is 1-to-1, which means its inverse will be 1-to-1. Well, if I were to graph the left-hand side of the parabola, then I would not have a reflection, and I would not have a 1-to-1 function, which means the inverse is not this full quadratic. It's only the quadratic to the right and equal to -2. So that vertex point right there, I have to recognize that it's only for x is greater than or equal to -2. If you leave your answer as just this, you'll get it wrong. So you have to encompass the restriction. It's only for x is greater than or equal to -2. And you can see that the domain and range of this one, so this is the domain and range of f, and the domain and range of f inverse is, well, domain is -2 to infinity, we're talking left to right, and then range is low to high. The low is -4 to infinity. And you should notice that the domain and the ranges switch, just like the x's and the y's. Okay? So this domain became that range, and this range became that domain. This right here, actually, finding the range of your original, if you start with a square root, will tell you what to write right there, because that becomes the domain of your inverse. Okay? All right. So now let's start with a quadratic that is already restricted. So if I start with a quadratic that is shifted to the right 3, so shifted to the right 3, so 1, 2, 3, and it's only for x is greater than or equal to 3. So when I graph my parabola, I'm only going to graph this side of it, right? So if I've got a parabola shifted to the right 3, but it's only for x is greater than or equal to 3, then I'm not going to graph that side, okay? So over 1 up 1, over 2 up 4, so 1, 2, 3, 4, and then over 3 up 9. And so this is the graph of my original function. This is the graph of f, or y, whatever. Okay, so as far as domain and range, domain is from left to right, and it says it right there, from 3 to infinity. And range is low to high. The lowest it goes is 0, and the highest it goes is infinity. Okay? For the inverse, let's find the inverse first. X equals y minus 3 quantity squared. If I want to solve for y, I'm going to take the square root. So the square root of x and then y minus 3. Now technically, I need the positive and the negative, and we'll discuss which one is the answer in the end. So I've got both the positive and the negative square root of x, and then plus 3 equals y inverse. Okay, well, I've got two different options. I've got the square root of x shifted up 3, so 1, 2, 3, this one. Or I've got the negative square root of x shifted up 3, which means this one. And so as far as which one's going to be a reflection of a function like this, I'm pretty sure it's going to be this side. And in fact, I already know the domain and range of my inverse, right? So I'm going to go ahead and write domain and range of f inverse. I know that the domain is the range of the original, so 0 to infinity. And I know the range is the domain of my original, which is 3 to infinity. So as far as range goes, I need the one that's 3 to infinity, not negative infinity to 3. But that also means that if I had started with x is less than or equal to 3, then this, so if y had equaled x minus 3 quantity squared for x less than or equal to 3, then this would be f inverse. Okay, just the bottom one. As it is the top one, so we'll say y inverse is the positive square root plus 3. So 1, 2, 3 over 1 up 1. The square root of 4 is 2, so over 1, 2, 3, 4 up 2. And the square root of 9 is 3, so that's 6, 7, 8, 9. 9 and up 1 more. And so this is the reflection of that across the diagonal. Obviously my scale's a little off, but yeah, if you were graphing on a grid, then that would be specifically the answer. Okay? All right. So last one. Graph and find the inverse of this linear function, but it's got a limited domain. So if I were to graph the function as is, then I'm graphing a linear function, but only from -2 to 4. Okay, I don't know what the y values are looking like, so I'm just gonna play around and see what happens. All right, I'm gonna go up 3, and I know that I'm only gonna graph until 4, and to the left I'm only gonna graph to -2. So I'm going to try and follow the slope and just use that to graph my points, but if I needed to, I could just plug in -2 right here. So -1/2 times -2 plus 3, and then plug in 4. And since we're talking about a line, if I figure out what this is and I figure what that is, I can just plot the 2 points and connect them with a line, because we're talking about a linear function. But I'm going to go ahead and just use my slope. My slope is -1/2, so I'm going to go from my y-intercept 3, down 1 and over 2. And then I'm going to go down 1 and over 2 again. And so that means at 4, I ended up at 1, and that makes sense because -1/2 of 4 is -2, and -2 plus 3 is 1. And then I'm going to go, instead of down 1 and to the right 2, I'm going to go up 1 and to the left 2. And I need to stop there, and that puts me at 4. So -1/2 of 2 is +1, and 1 plus 3 is 4. So I connect these 2 points, and don't draw past them because that is my original function. Okay? So from -2 to 4. Its domain, obviously, is -2 to 4, and its range is y value 1 to y value 4, which means I already know the domain and range of my inverse. So this is the domain of and range of y, and this is the domain and range of y inverse. The domain should be the range of the original, so 1, 4, and the range should be -2, 4. Okay, let's find the inverse and make sure that that works out. So x equals -1/2 y plus 3. So I'm going to subtract the 3, and then I'm going to multiply by a -2 on both sides. So -1/2 times -2 is +1. So y inverse equals, and then distribute my -2, -2x plus 6. Okay, so I'm going to, let's see, I did it with the blue. Okay, we're going to graph this, but remember we've got to identify the rest of, can't even see what I wrote. Okay, so I subtracted 3, and I got this green, and then I multiplied by -2 to undo the -1/2 and got -2x plus 6. So my inverse is -2x plus 6, comma. I have a domain restriction, I've just got to figure it out. I mean, actually I already know it. It's just right here, right? So I could say from 1 is less than or equal to x, which is less than or equal to 4, because that is the domain of my inverse because it was the range of my original. All right, but if I'm going to go sketch it, I've got to go up to 6. So 1, 2, 3, 4, 5, 6. And I have a slope of -2 over 1. So I'm going to go down 2 and over 1 until I reach, I just kind of made my first mistake on this one. The function I just said has a domain restriction of 1 to 4, and then I graphed it at 0. So this point does not exist, actually. So I know that the y-intercept is 6 if I were to sketch it that way, but I'm just going to use that as a guide, and I know I need to go down to and over 1. This is my starting point, which I can figure out by plugging in 1. Negative 2 times 1 plus 6 is 4. So at 1, I should be up at 4, and I am. And then I'm going to go down until I reach x equals 4. I'm going to keep graphing. So down 2 and over 1, down 2 and over 1, down 2 and over 1. And so this is the reflection across the diagonal. Okay? Again, I could have just plugged in the endpoints and said negative 2 times 4 plus 6, which is negative 2, and I would have gotten my 2 corresponding. That means the point 1, 4 is the first endpoint, and the point 4, negative 2 is my second endpoint, and just connected them. All right? Okay, I don't have any extra homework for you. I will get this to you. I will talk about this again tomorrow, and I will give you the homework then. All right.